learning target for this video, I can solve a system of equations by graphing. A system of equations is when you have more than one equation on a coordinate plane and you're looking for the point of intersection, because the point of intersection works for both of the equations, or if you have more than two, the point of intersection would have to work for all of the equations. So here we go. Our first example, we're given two equations. Example number 1, x equals -1, is a undefined slope. So we have a vertical line with a x-intercept at -1. So an x-intercept at -1, a vertical line. And I encourage you highly, if you're doing these by hand, to use a straight edge, because to find the intersection point, you really need your lines to be as accurate as possible. The second equation is y equals -x plus 4. We have a y-intercept of 4, so I plot my first point on the y-axis at 4, and a slope of -1, meaning that I'm going to rise 1 and left 1 for that negative, or backwards, I'm going to down 1 and right 1 for that negative. And again, I would use a straight edge to draw my line as straight as I possibly can so that I can clearly see my intersection. The solution is the intersection point. So the solution is a coordinate. It is a coordinate. It should have both an x and a y value. So I'm going to find the point of the intersection. This point right here, its x and its y value. The x value is -1. The y value is +5. On my next practice problem, I have my first equation, y equals -x minus 6. I have a y-intercept again at -6 and another slope of -1. So I'm going to go up 1 and left 1 for that -1. I'm going to do that a few times just to help me draw a nice, accurate line. So let me get my straight edge going here. I don't really have a straight edge on this whiteboard. My second equation is y equals -2. And this has a slope of 0, so my line is horizontal. I have a y-intercept at -2, and then I have a horizontal line. Here we go. Once again, my solution must be a coordinate, so it's written as a coordinate. The x value is -4. Here is my intersection. The x value is -4. The y value is -2. For our next example, our first equation is given y equals x plus 4. My y-intercept is +4. My slope is +1. So I'm going to rise 1 and run 1. And I'm probably going to put a couple of extra points going backwards as well, just to help me have a nice straight line. My second equation, 4x plus 1, has a y-intercept of +1 and a slope of 4, meaning that I have a rise of 4 and a run of 1. 2, 3, 4 right here. And 1, 2, 3, 4 right here. Again, I use a straight edge and try to get this line as straight as possible. Okay. And I'm looking for the intersection point. This time, had my line been drawn a little straighter, my intersection would clearly be at that point. I write my solution as a coordinate, x value 1, y value 5. I always write a coordinate with the x value first. My next equation is slightly different. I do have the first one, y equals x plus 1. So we are going to put our y-intercept at 1, and we have a slope of 1, so rise 1 over run, and we're going to draw our line. Okay, I'm sorry, the calibration seems to be a little crazy here on my board. Let me try that line again. So, intercept and slope of 1. Try this again. That's a little better. Now, my second equation, 2x plus y equals 10, is actually written in standard form. So to make this equation easy to graph, I need to rewrite it into slope-intercept form. So I'm going to subtract the two x's from both sides of this equation. And I'm left with y equals negative 2x plus 10. So my y-intercept is 10, and my slope is negative 2. Of course, I always think of the slope as a rise over run. So I'm going to rise negative 2 in run 1. And again, I'm going to do that a couple of times to try to help me make sure that I have a nice straight line format. Trying to get it through there. Okay. I can see, though, that my coordinate of intersection is here, and my x value is 3, my y value is 4, so that would be my solution.